Question 1. Figure 1 shows an electric car being recharged. It's a car, there's a power cable and a charging station. Says the charging station applies a direct potential difference across the battery of the car. What does direct potential difference means? Now, remind yourself that there are two types of power supplies. One is called alternating power supply and the other one is called direct power supply. The examples of direct power supply include like cells and batteries, whereas the power supply which is alternating is the one that we use like the electric supply in our houses. So in this case, it says direct potential difference. This means the PD is always positive or always negative. So it will not change its polarity. It will remain always positive or it will remain always negative. If it was alternating potential difference, then it will change its polarity between positive and negative value. Next part asks you to identify the equation that links energy, power, and time. So if you remind yourself, there's an equation for power. Power equals E over T. If you rearrange this equation, you'll end up with P times T equals E. So you just have to check out of these four which one is similar to these two equations. I can see in the first one, this is not the right equation because they both are not the same. Second equation is again not the same as this one, but I can see in this case, this is similar to this equation. So the answer is C. Next part says the battery in the electric car can store 162 million joules of energy. So this is the value of E. The charging station has a power output of 7200 watts. So this is the value of power. It says calculate the value of time for the full recharge from 0. So all we have to do is we just have to plug in the values. My equation is P equals E over T. I just need to replace P with 7200. Energy is 162 and 6 zeros divided by T. Make it simple for yourself. You can put 1 in the denominator on the left side, and now you can cross multiply. So when you cross multiply, you will end up with 7200 times T equals 162 million. You divide both sides by 7200. This side, they'll cancel out. And if you plug these values in your calculator, you'll end up with an answer, and the answer will be 22,500 seconds. Next part again is similar to 1.2. It says which equation links current, potential difference, and resistance. So there's an equation for which links these three variables, that is V equals I times R. You just have to compare which option is similar to this one, and in this case I can see it's D. Next part says the potential difference across the battery is 480 volt. There's a current of 15 amps in the circuit connecting the battery to the motor of the electric car. Again, identify this is the value of V, this is the value of I. Question says calculate the value of R. All you have to do is rewrite that equation and substitute values, and you'll end up with your answer. So instead of V, I'll write down 480. For I, I'll write down 15. R has no value at the moment. I need to calculate it. Now to get rid of 15 from the right side, I'll divide both sides by 15. This will cancel out. I'm left with R only on the right side. If you divide 480 by 15, you'll end up with an answer, and that will be 32 ohms. Next part says different charging systems use different electrical currents. Charging system A has a current of 13 amps. Charging system B has current of 26 amps. The potential difference of both charging stations is 230 volt. How does the time taken to recharge a battery using charging system A compares with the time taken using charging system B? So the question talks about the time taken. In both cases, the final amount of energy stored in the battery will be the same. So I can say I have to figure out the equation for energy, that is E equals V times I times T. I know based on my understanding this is fixed for both of them. this is also fixed for both of them because they've told us that they both have potential difference of 230 volt. Now I need to focus only on this section. So I can see here for this value to remain constant, if the value of I increases, then the value of time will decrease. In this case, I can see that the current for charging system is double, so the time taken will be lower. So I can say should take less time. Now let's explore the given option. It says time taken for system A is half the time of system B. That's not right, because in this case we said time for system B will be smaller. Time taken using system A is same. That's wrong as well. Now we are only left with one option. It says time taken using system A is double the time of system B. That makes more sense. So the answer is this.